This is figure 41-6 or 41.6, and what I wanted to point out on this particular diagram is the lecture states that this series circuit has a 2 ohm resistor and a 4 ohm resistor, and current through the entire circuit is going to be the same. Doesn't matter what the voltage drop is. So for instance, on this one here, you've got a voltage drop of 4 volts, and you've got a voltage drop of 8 volts here on this resistor, but the amperage is still going to be the same. And one of the things I wanted to show you on this is, as we move through the examples, I've got a way that I solve these electrical equations, and I wanted to show it to you. It works for me. If you have a better way to do it, that's great. You can use that way too. But this is just a way that works for me. And what I do is I usually draw a calculation answer sheet up here. And the first thing I do is identify the circuit. So is this a series circuit? Is it a parallel circuit? Is it a series parallel circuit? So the way to do that is by looking at the wires and looking to see where your path for current flow is. So if I come out of the battery on the positive side and go around here all the way around the circuit, there's only one path for current to flow. So that means that this is a series circuit. So I've identified this as a series. Then what I do is I fill in all of the blanks that I know. So on this one here, we have all the information already. But what I would do is I would fill in, so for instance, voltage total is 12. Amperage total is 2, and I can fill in my resistor values, which is 2 ohms for this one, or sorry, 2 ohms for R1. If I can write here, let me write the correct value in. So this is 2 ohms, and we've got 4 ohms. And then once I have the basic information in, what I can do is I can look at my circuit laws. Now, we just talked about in the series circuit, amperage is consistent. So amperage is the same all the way through the series circuit. So I can go ahead and put 2 amps in both R1 and R2 because amperage is the same throughout the entire circuit. So now I've got 2 of my factors. And so when it comes to Ohm's law, if you remember, Ohm's law is E over I R. Or in other words, another way to express this would be volts, amps, ohms. So you have electromotive force, or volts, divided by intensity, or amperage, times resistance. If you know 2 of these 3 factors, you can figure out the other ones. And so, for instance, up here on the top, I know what my voltage is, I know what my amperage is, so voltage divided by amperage gives me resistance. So 12 divided by 2 is 6. And vice versa is true over here. So if I know my amperage and I know my resistance, I know my amperage, I know my resistance, I can just multiply. Because this right here is multiply, this right here is divide. So 2 times 2 is 4. And 2 times 4 is 8. So 8 volts, 4 volts. And to double check myself to see if I did this right, 8 plus 4 equals 12. 2 is constant. 4 plus 2 equals 6. So that's a way that you can figure these circuits and double check yourself to make sure that everything is right. So I just wanted to show you that on this circuit. Now we'll go through and I will walk you through the other examples in the PowerPoint presentation so that you can see how that's done.